Hello and most welcome to Heidegger 1043, and I will speak about the book The Mind in the Brain by David Redish. It's very interesting because it goes into what we mentioned before about the cerebellum, the decision-making mechanism in the brain, the part of the brain that tells the speed, the rhythm, and the successfulness of thinking. This is what makes thinking either more effective or less effective, more working or less working. It is also what decides whether we understand something or the degree of understanding. And it's most definitely a book that takes up the latest things within neurology, and that's a vision that plays a big role also in the understanding of the philosophies that we're taking up in this series. There are so many of them, but the traditional way of teaching them has been quite awful. People are asked to read in the books, and when it comes to the most advanced philosophers, to make up their own understanding without an action, without a direction. Everything is left to chance, so the student in the end can have any understanding whatsoever. The only thing they need in the end is to have the outer surface, the vocabulary, the concepts. And speaking of a great philosopher of day like Martin Heidegger, it's an incredible disgrace. You have no idea if the student goes anything beyond the concepts. And since his destruction is all about going beyond the concepts, not staying within them, not adhering only to surface, his whole mission, his whole idea, his want is being ridiculed by modern educational system in their naivety and ignorance. The teacher, the professor have to make sure the message goes through, and that will not be enough if action is not part of the place. A passive understanding is proven always to be different. It has never ever happened that two people read the same book and you don't keep check of their activity in the cerebellum, how they move or what the posture is, that they could have the same understanding. It won't even be similar. And this is one of those things that we really pointed to in the lecture series, the incredible naivety of current educational system and how they obliterates, destroys traditional knowledge and the great authors. They should be ashamed for what they have done. I think it's absolutely ludicrous what, for instance, mechanical analytical philosopher thinks the meaning is in the book somehow, and you can just hand out the books and then you have some sort of verbal lecture. That will not work at all. Action is what tells how deep the understanding is, and in the end a person like Martin Heidegger and Jacques Derrida is turning into, as Rodolphe Cochet would call, mere puppets or ridiculous plastic imagery of the real thing. Just give me a second here. One could say this is a criticism of monosemic idea or the monosemic illusion, because it's not scientifically possible with a monosemic take on reality. But what monosemism assumes is that there is a regulated meaning in books and in lectures, in words, like a sort of a correctness scheme. And this scheme can secure that you can just hand out books and ask students to read and make disgrace of the pure meaning. To have the meaning, you need the movement, you need to be in contact with the dingen, because we are in reality and our understanding is not separable from reality. It's absolutely ludicrous. And I would say for every time you take that step, you take a step away from knowledge. Because this is the world. Our understanding of the world has the structure of this world. It has the structure of a body, it has the structure of a direction, it has the structure of our balance. And of course that plays an enormous part. And you have no chance of getting the same meaning otherwise. Actually, David Bradel clearly showed that there is no meaning outtake anymore in education. There is no learning anymore. It is the sound or unsound repetition of concepts only. No deepening of understanding. And since I know these great philosophers have something to give us, we will be wise not to ignore the message anymore, or relegate it horribly thinking to an unbalanced reading when you sit like this or crutch, which takes away maybe 80-85% of understanding, and it takes away the most important part of the understanding, and that is depth. So a little here, it's a start here, and remember please, what David Redish called decision is also the wave or the movement. I think that could be something that makes it easier to understand to what he's referring to or what he's pointing to. What is a decision? A little poem. Snow flurries from the roof as squirrel skids to a stop, leap into the unknown. And here's a little disclaimer. In order to be able to scientifically measure decision making, we define decisions as taking an action. There are multiple decision making systems within each of us. The actions we take are a consequence of the interactions of those systems. Our irrationality occurs when those multiple systems disagree with each other. Because we like to think ourselves as rational creatures, we like to define decision as the conscious deliberation over multiple choices. But this presumes a mechanism that might or might not be correct. If we are such rational creatures, why do we make such irrational decisions? Whether it be eating the last French fries that just was one more than we wanted, or saying something we shouldn't have at a faculty meeting, or the things we did that time when we were drunk in college. We have all said and done things that we regret. Many a novel is based on a character having to overcome an irrational fear. Many an alcoholic has sworn not to drink, only to be found a few days later in the bar, drink in hand. We will see later in this book that the decisions that we make arise from an interaction or multiple decision-making systems. We love because we have emotional reactions born of intrinsic social needs and evolutionary drives. We decide what job to take through considerations of the pros and cons of the imagined possibilities. We can ride a bike because we have trained up our procedural learning system, but it can also be hard to break bad habits that we have learned to do well. We will see that these are only a few of the separable systems that we can identify. All of these different decision-making systems make up the person you are. The idea that our actions arise from multiple separable identifiable components has a long history in psychology, going back to Freud or earlier, and has gained recent traction with theories of distributed computing, evolutionary psychology, and behavioral economics. Obviously, in the end, there is a single being that takes an action, but sometimes it's helpful to understand that being in terms of its subsystem. The analogy that I like, which I will use several times in this book, is that of a car. The car has a drivetrain, steering system, brakes. Cars often have multiple systems to accomplish the same goal. For instance, the foot pedal brake and the emergency parking brake, or the electric and gasoline engines in a hybrid like the Toyota Prius. The psychologist Jonathan Haidt likes to talk of a rider and an elephant as a metaphor for the conscious and unconscious minds, both making decisions. But I find this analogy unsuitable because it separates the self from the other decision-making systems. As is recognized by Haidt at the end of his book, you are both the rider and the elephant. When a football star talks about being in the zone, he's not talking about being out of his body and letting some other being take over. He feels that he is making the right decision. In fact, he is noting that his procedural habit system is working perfectly and is making the right decisions quickly and easy. When you are walking through a dark forest and you start getting afraid and you jump at the slightest sound, that's not some animal reacting, that's you. It's a classical example of Pavlovian action selection system. Sometimes these systems work together, sometimes they work across purposes. In either case, they are still you. Do I contradict myself? Asked Walt Whitman in his long poem, Song of Myself. Then I contradict myself. I am large, I contain multitudes. What a nice poem. Walt Whitman, the American author and poet. So how do we determine how these multiple systems work? How do we determine when they are working together and when they are at cross purposes? How do we identify the mechanism of Whitman's multitudes? To study something scientifically, we need to define our question in a way that we can measure and quantify. Thus, we need a measure of decision making that we can observe so we can compare the predictions that arise from our hypothesis with actual data. This is the key to the scientific process. There must be a comparison to reality. If the hypothesis doesn't fit that reality, we must reject that hypothesis, no matter how much we like it. One option is to simply ask people what they want. But of course, the idea that we always do what we say we want makes very strong assumptions about how we make decisions. And anyone who has regretted a decision knows that we don't always decide to do what we want. Some readers may take issue with this statement, saying that you wanted that decision when you took the action. Well, just because you regret that night of binge drinking when you have an hangover in the morning doesn't mean you didn't want all those drinks in the night before. Other readers might argue that a part of you wanted that decision even if another part didn't. We will come to a conclusion very similar to this, that there are multiple decision-making modules and that the members of Whitman's multitudes do not always agree with each other. Much of this book will be about determining who of those multitudes are and what happens when they disagree with each other. As a first step in this identification of the multitudes, careful scientific studies have revealed that a lot of conscious decisions that we think we make are actually rationalizations after the fact. Well, that's Benjamin Libet. For example, the time at which we think we decide to start an action is often after the action has already begun. In what are now considered classic studies of consciousness, Benjamin Libet asks people to perform an action, such tapping a finger whenever they wanted to, while watching a dot move around a circle. The people were asked to report the position of the dot when they decided to act. Meanwhile, Libet and his colleagues recorded electrical signals from the brain and the muscles. Libet found that these signals preceded the conscious decision to act by several hundred milliseconds. Both the brain and muscles worked by manipulating electricity, which we can measure with appropriate technologies. With the appropriate mathematics, we can decode those signals and determine what it is happening within the brain. Libet decoded when the action could be determined from signals in the motor areas of the brain and compared it to when conscious thought the action had occurred. Libet found that the conscious decision to take an action was delayed, almost as if consciousness was perceiving the action rather than instigating it. Several researchers have suggested that much of consciousness is a monitoring process, allowing to keep track of things and step in if there are many problems. Much of the brain machinery is doing this sort of filling in, are making good guesses about the world. Our eyes can focus on a very small area of our visual field at a time. Our best visual senses are an area of our retina that has a concentration of cells tuned to color and specificity in a location called the fovea. This concentration of detectors at the fovea means that we are much better at seeing something if we focus our eyes on it. Our vision focuses on a new area of the visual world every third of a second or so. The journeys between visual focusings are called saccades or saccades. Even while we think we are focusing our attention on a small location, our eyes are making very small shifts called microsaccades. If the visual world is aligned to our microsaccades so that it shifts when we do, the cells adapt to the constant picture and the visual image grays out and vanishes. This means that most of our understanding of the visual world is made from combining and interpreting short-term visual memories. We are inferring the shape of the world, not observing it. And I would say this is how Heidegger sees perception. It's the comparison with a visual memory. One of the microsaccades happened 1/3 of a second earlier, and the comparison with the present microsaccade, that is the visual world. So observing it, as Redish is mentioning here, is actually an inkling or a pointer to the representational idea of metaphysics of presence. In a simple case familiar to many people, there is a small location on our retina where the axons for the outpost cells have to pass through to form the optic nerve, sending the visual signals to the rest of our brains. This leaves us with a blind spot that must be filled in by the retina and the visual processing system. Our brain normally fills in the blind spot from memories and expectations from the surrounding patterns. In a similar way, we don't always notice what actually drives our decision-making process. We rationalize it, filling in our reasons from logical perspectives. Some of my favorite examples of this come from the work of V.S. Ramachandran, who has studied patients with damage to parts of the brain that represent the body. A patient who is physically unable to lift her arm denies that she has a problem and merely states that she does not want to. When her arm was made to rise by stimulation her muscles directly, she claimed that she had changed her mind and raised her arm because she wanted to, even though she had no direct control of the arm. In a wonderful story told by Oliver Sacks, a patient claims that his right hand is not his own. When confronted with the fact that there are 4 hands on the table, 2 of his and 2 of the doctor's, the patient says that 3 of the hands belongs to the doctor. "How can I have 3 hands?" asks the doctor. "Why not? You have 3 arms," replies the patient. And this is a sound, rational, lucid patient saying this. So this has a lot to see why we today think we have knowledge, we think we understand different things, but we are instantly making that understanding up, as proven by David Bradell, Benjamin Libet, and specifically by Ian McGilchrist. Shows that what we think is knowledge can be proven to be no knowledge at all, but still we claim to have it because it suits our purpose to believe that. But knowledge we do not have. Our bodily position and the training of the cerebellum is much too weak to give knowledge of the world, as well as not being possible to make room for decision making with predictive power. Our decisions will be and are always defective. They should be, because we have no contact with the world. To say that our decisions were correctly but the world was wrong is a very common solution, but it's very similar to the free arm construction. In his book "Surely You're Joking, Mr. Feynman," the famous physicist Richard Feynman describes being hypnotized. He wrote about how he was sure he could take the action, in this case opening the eyes, even though he had been hypnotized not to. But he decided not to in order to see what would happen. So he didn't, which was what he had been asked to do under hypnosis. Notice that he rationalized this decision. As Feynman himself recognized, even if he said, "I could have opened my eyes," he didn't. So what made the decision? Was it to some effect a hypnosis on the brain, or was it that he didn't want to? How could we tell? Can we tell? I think that's really interesting, that we think we decide not to open the eyes just to make sort of a joke. But this is exactly what the hypnothecists were inducing. I think that is how our systems today are incredibly weak for influences, because we don't have any measurement to know if the decisions we take are our own or coming from someone else or something else. And I will in a later lecture go back to how influenced we are by conformity, something that Heidegger called Das Man. I think Das Man in itself is well worth a lecture by itself. And this is also something taken up by Wayne D. Wire and Gadamer, the authoritarian man, which is the modern man. And they both claim and point to something I agree with, and that is that modern man is no longer an autonomous creature, because he will always say that his actions were conscious, deliberate, and predictive. It doesn't matter if he's shown research report like Benjamin Libet and et al. that cannot be the case. It's proven beyond doubt. He would still think he's consciously aware of his decisions. And you can imagine the risk that put people in, the peril, not being responsible or not even able to be responsible for their own lives. Well, I continue on page 6 here. Many of the experiences we are going to talk about in this book are drawn from animals making decisions. If we're going to say that animals make decisions, we need to have a way of operationalization that decision. It's hard to ask animals what they think. There are methods that allow us to decode information represented within specific part of the brain, which could be interpreted as means of asking an animal what it thinks. However, unlike asking humans linguistically, where one is asking the overall being what it thinks, decoding is asking a specific brain structure what it is representing. Of course, one could argue that assuming what people say is what they think, assume that humans are unified beings. As we will see, as we delve deeper into how decisions are made, humans, like other mammals, are a mixture of many decision-making systems, not all of which are always agree with each other. Just as Libet experiments suggest that the part of brain can act without consciousness, there are representations in the brain that are unable to affect behavior. In a remarkable example, Pearl Chu and Terry Lawrence and Reed Montague found that signals in both smokers and non-smoker brains that represented not only the success in a decision made, but also what they could have done if they had made a better choice. This recognition of what they could have done is called a counterfactual and enables enhanced learning. It is now known that both rats and monkeys can represent counterfactual reward information as well. These signals appear to use the same brain structures that Chu, Lawrence and Montague were studying, and to be the same structures involved when humans express regret. Counterfactuals enhance learning by allowing one to learn from imagined possibilities. For example, by watching someone else make a mistake. Or in the example used by Chu, Lawrence and Montague, if I had taken money out of the stock market last week, I wouldn't have lost all that money when it crashed. End of quote. I think that is brilliant. While signals in both groups' brains reflected this counterfactual information, only non-smokers' behavior took that information into account. If we want to understand how decisions are made and how they go wrong, we are going to need a way to determine not only the actions taken by the subject, but also the information processing happening in his or her brain. Certainly, most non-human animals do not have language, although there may be some exceptions. Nevertheless, it would be hard to ask rats, pigeons or monkeys for that case, all of which we will see making decisions later in the book, what they want linguistically. Given that, it's also hard to ask humans what they really want. We will avoid this language problem altogether and optionalize making a decision as taking an action, because taking an action is an observable response. I say hooray to that. This is very similar to what is known in behavioral economics as a revealed preference. Economic theory and the concomitant new field of neuroeconomics generally assumes that those revealed preferences maintain a rational ordering such that if you prefer one thing, say chocolate ice cream, to another, say vanilla ice cream, then you will always prefer chocolate ice cream to vanilla, even if you are ever in the same situation. We will not make that assumption. Similarly, we don't want to assume that the person telling you what he or she wants actually reflects the choices a person will make when faced with the actual decision. Given the data that our conscious observation of the world are inferred, and the data that are spoken explanations or rationalization, some researchers have suggested that our linguistic explanation of our desires are better thought of as a speech of a press secretary than the actions of an executive. Well, I also say hooray to that. Thus, rather than asking what someone wants, we should measure decisions by giving people explicit choices, asking them to actually choose. We will encounter some of these strangeness discovered by these experiments in the subsequent chapters. Often, experimentalists will offer people hypothetical choices. It is particularly difficult to get funding to provide people a real choice between $10,000 and $100,000, or to give them a real choice whether or not to kill one person to save 5. Instead, subjects are asked to imagine a situation and pretend it was real. In practice, the few cases where they have been directly compared, hypothetical and real decision-making choices tend to match closely. But there are some examples where hypothetical and real decisions diverge. These tend to be with rewards or punishment that are sensory, immediate, and what we will recognize later as Pavlovian. A classic example of this I call the parable of the jelly beans. Sarah Boyson and Gary Benson tried to train chimpanzees to choose the humble portion. They offered the subject 2 trays of jelly beans. If they reached for the larger tray, they got the smaller one, and the larger was given to another chimpanzee. However, if the deciding chimpanzee reached for the smaller tray, he got the larger tray and the smaller one was given to another chimpanzee. When presented with symbols, Arabic numerals that they had previously been trained to associate with numbers of jelly beans, subjects were able to choose the smaller group. But when the choices were physical jelly beans, they were unable to prevent themselves from reaching for the larger group of jelly beans. Other experiments have found that more linguistically capable animals are more able to perform the self-control behaviors. This may be akin to the ability to talk to ourselves out of doing things that we really want to. I am not craving that cigarette, but I don't want it, I really don't. I think this is incredibly important because this goes for learning as well, and this is one of those incredible obstacles that are never discussed or expounded, and that is our need to understand something, our wish to understand something is the most stopping factor. And if we don't have a system to make us patient, to reach out for the jelly beans as an example of chimpanzee, be patient with knowledge, be patient with perception. We will not have perception, neither will we have knowledge. It is this direct urge to directly grasp something And this is actually incredibly much harder to get around than actual temptations like a piece of cake or a cigarette if you're a smoker, an alcoholic, a glass of wine, and so forth. I think in my case would be a cup of coffee, which I really strive for now. I think this is extremely pertinent. I recognize so many things from Heidegger and Redish here. How centrism is something we can't help. It can still be exposed, but how do we heal it? And this is something that more Rodolphe Gachet pointed to than Jacques Derrida, for instance. He wanted us to learn how to deconstruct, to stay within the waiting zone and let knowledge speak for itself, because both our inner worlds and the outer worlds will be, to a certain degree, more or less blocked off if we are too anxious. And whereas there are simple methods of hindering myself from reaching out for the candy or the nice food, if I want to lose weight or whatever it is, or the temptation to take the staircase instead of walking up a steep hill. It is much harder to do that when it comes to the intellect, and that is why I'm 100% certain that our stumbling in the thinking, that maladjusted cerebellum that David Brerel talking about, can only be adjusted with liturgy, sharp perception, and a method that sort of stops every moment. And once you learn to stop, I think you intentionally can do what Frederick Matthias Alexander called inhibition. Something also pointed out by Raymond Dart, the South African neurologist and also explorer of human origin. Next, he is going to mention the marshmallow experiment. And since I mentioned that so often before, I will wait and I'll read a little bit more about the book myself, and I get back to that in the next lecture. It is amazingly interesting, and it's a light read for once. If you need some relaxing read, his book is excellent. Well, I put in more reference to the books later on in a future lecture. I say thank you very much and have a very pleasant afternoon. Bye for now.